Alright, I'm streaming now.
Nice.
Alright, let's see what Professor Leonard's gonna say today.
Further, did you guys understand the tangent problem? Not just if you're okay with the tangent problem. You understand the idea of a limit? Moving a point really close to, but never actually getting there. Again, why can't we get there? Need 2 points. Yeah, that'd be fun. Okay, cool. Now we're ready. I'm excited. First little step off into calculus land. Do you trust me? Shouldn't.
Y equals x squared.
What's up?
He drew a graph that said y equals x squared.
Y equals x squared. It's a parabola or something.
Here's the goal to this problem. I want us to find the equation of the tangent line to this curve at a certain point. The tangent line. Here's the goal to this problem. I want us to find the equation of the tangent line to this curve at a certain point.
He wants to find the equation to the slope of the tangent line of a certain point that he just picks out on the curve.
Okay.
Specifically that one. 1, 1. Well, let's go over to 1, 1, and let's put a point there. So P.
Alright, so we go to 1, 1, and we put a point. And so we gotta find the equation of the tangent line to the point 1, 1.
P is the point 1, 1. I'm going to walk you through how we're going to do this right now, okay? I'm going to walk you through how we're going to make up a tangent line using this idea. Are you ready for it? Over here on this idea, we had 2 points, right? P set in stone, you're not going to move P. What other point do we have? We're going to make a point Q. Q. What's the coordinates for point Q? Why don't you tell me? What's coordinates for point Q? We can't use actual numbers, right? That wouldn't be very good. So I know 2, 4 would be on there, and 3, 9 would be on there, 4, 16, and so on. But I want you to use actual points. In general, what are the points for, or what are the coordinates for any point? X, Y. Very good. Okay, X, Y. So now write down X, Y, and have your eraser handy. Have your eraser handy because I'm not going to have X, Y. I want to keep this in terms of one variable. Now, using your knowledge of what the function is, what's the function? Y equals what?
X squared.
Say it again. Y equals what?
X squared.
Y equals?
X squared.
So instead of having X comma Y, would it be okay with you?
Wait, so what's he gonna do with this? He's gonna write the function?
I had X comma X squared.
X comma X squared. Wait, what?
Yes, no? Because Y is X squared, right? So that won't matter.
Oh, because y is x squared.
So erase that, and I want you to put X squared.
True.
Cool.
But why write it like that?
All right. Now we have this secant line going from P to Q. P is a fixed point 1, 1. Q is a movable point x comma x squared. Would you agree that any point on this line will have the coordinates x comma x squared? Yeah. No matter what I plug in, right? So that movable point, that's going to have the same coordinates all the way down. Now we have this secant line. Here's what we want.
Alright, and then we got our secant line going through these.
No, we know that the equation for a line is y minus y1 equals m x minus x1, true? What we're trying to find is the equation for a tangent line. Here's what the equation for a tangent line would be. Pay close attention. It would be y minus y1, that's the same, equals the slope, but a specific slope. It would be the slope of the tangent line, true? Whatever the tangent line slope happens to be. So the slope of the tangent line, and then x minus x1. Now, the cool part about this, I'll recap this in just a bit. The cool part about this is we already have a point. What's my fixed point that I have? I already have 1, 1. So really what this comes down to is, can you find the slope of the tangent? That's why I said finding the slope of a curve at a point is the big deal for calculus. You already have the point. That's the easy part. The slope is the hard part. So we're going to try to find right now the slope of the tangent. Are you ready for it?
Yeah.
You sure? We're going to use the idea of slope of a secant. So we're going to take a break right now. We're going to come back to this. In case you're just a little bit lost, here's what we've done so far. This is y squared. I gave it to you. We've fixed one point according to my problem. That's 1, 1. We've made up another point, a movable point, q. Q is at x comma x squared. Where did the x squared come from? That's because it's y. All right, great. We now know that the equation of a line is this, so therefore the equation of a tangent line would be the same exact equation. It's just we have the slope of the tangent line. The problem is, it's very hard to find the slope of a tangent line without doing the limiting idea. You can't do it because there's only one point there. So we're going to have to use the idea of a secant and make it into a tangent line by moving Q really close to P. Did you get the idea? Basically doing that with this problem. So let's take a look at the slope of a secant. Our specific secant. Hey, by the way, do you remember the slope in general, the slope formula?
Y minus y sub 1 over x minus x sub 1. Is that the slope formula, Nick? Can you fact check?
I believe so, yeah.
Alright, let's see.
Yeah. Or y sub 2
Slope
minus y
is
sub
1
1. I
over
think
what?
that's interchangeable with
Same
y.
thing.
Okay, great. In
Yeah.
terms of our coordinates, slope is delta y over delta x. Specifically, in terms of our coordinates, what is our slope? That's what I'm looking for. y2 minus y1, yeah, over x2 minus x1, otherwise you get the negatives of that slope. So y2 minus y1, x2 minus x1. Do you follow? How many people feel okay with it so far? Just slope formula. What we're going to do, we're now going to find the slope of our secant. We've got the secant on the board, right? The secant will be the slope, I'm sorry, the slope of the secant will be the slope from points P to Q. Agreed? Let's plug in these coordinates. We only have them on the board. Plug in these coordinates into that formula. In our case, our y...
Okay, so to find the slope of the secant, you plug in, let's see, it'd be x squared minus 1 over x minus 1. I still have no idea where he's going with this.
Our y2 would be x squared. What's our y1? Not x. Would be 1. What's our x2? What's our x1? Okay, y2 minus y1 over x2 minus x1. Not sure if you're okay with that. So what we'd have for the slope of our secant is y2 minus y1 over x2 minus x1. Are you okay with this so far? Find out where the slope comes from. There's a couple notes I want to make at this point. First, I'm reiterating a lot of stuff here. I know that I am. I'm doing it on purpose because these are the key points of calculus, all right? You need to understand what we're doing. I would hate for you to get through this class, right, and at the end of it, know how to take derivatives and integrals and have no idea what you're doing. You can be successful on just doing derivatives and integrals in this classroom. But if you don't understand what it is you're actually doing with those things, you don't even know what they are right now. But if you don't understand what you're doing, it's irrelevant. You're just doing formulas. It sucks. If you know what it comes from, what you're actually doing, I'm going to make sure you know, by the way, it's a little bit more interesting and you can apply it to more things. Do you get the picture? So right here, what we're doing, step number one, is if we move Q close to P, this is going to become this. Do you agree? As Q, I'm going to use a new symbol here, approaches P. That means as Q gets really close to P without touching, the slope of the secant line approaches the slope of the tangent line. Would you agree with that statement? That's over here right now. You agreed with it already. Haha, I tricked you. As Q gets close to P, the secant gets close to the tangent. True? That's what this says right now, okay? As Q gets close to P, the secant gets close to the tangent. How close? It depends on how close we get these things. If we get them so close it doesn't matter, then these become so close it doesn't matter. Agree? It's kind of neat, right? It's a cool idea. Now, the problem is, here's note number one. Here's note number two. This is interesting, right? Where are we trying to find the slope? What point? 1, 1. Well, and what's the x-coordinate for 1, 1?
1.
To find the slope of anywhere, you plug in that value, right? This gives you the slope of the secant line, true? Plug in 1. Plug in 1. What happens?
Oh, wait, it turns into a 0.
No, you don't get 0. You get 0 over 0 over 0 is not 0. That's a big problem. 0 over 0 is undefined, right? Isn't that an issue? This is why, folks, this is the reason why you cannot have the point getting, listen, you can't get Q close to P because if you plug in 1, it's undefined. That means that you have the same point. So you can't let x equals 1, that's big time.
So x cannot equal 1, or else it's undefined. It's kind of crazy.
That means double important. You can't let x equal 1. This is why we can't let Q equal P, because we only have 1 point, right? You can't find the slope. It fails. It's undefined at that point. This is why Q can't equal P. If it does, if you try to find the slope of the secant at that point, move Q all the way down and plug in the x-coordinate, it's the same thing. You're going to get something that's undefined because you're trying to find the difference between points that don't exist, a difference that doesn't exist. And that's going to be, you're divided by 0. There's no difference in the x-axis. That would mean you're divided by 0. You get something that's undefined. You get an undefined slope. That's a bad thing. So we can't let Q get all the way to P. True? All right. What can we do? Now this is going to blow your mind. You ready to get your minds blown? Like a mind grenade. You ever seen Yes Man? Watch Yes Man. It's so fun. Had a Ripple. Y'all have Ripple? It's called Ripple. Right. Have you not seen it? That just sounded really stupid. You watch Yes Man. It's pretty funny. Now, so, next part. Gonna blow your mind. Can you factor that? In fact, learning what.
Oh, you're just gonna factor that? No shot. What is bro doing? So he's gonna cancel out the x minus 1. So that's only x plus 1.
What we knew about asymptotes, stuff like that, you know that if you have
Okay.
0 over 0, it's factorable because of, well, some stuff in mathematics that I haven't bored you with yet. But if you ever have some number that makes 0, it means that that's a factor. If you have some number, the same number that makes two polynomials 0, it means they have a common factor. We've got that, but if you ever have factor that. In fact, learning what we knew about asymptotes, stuff like that, you know that if you have 0 over 0, it's factorable because of, well, some stuff in mathematics that I haven't bored you with yet. But if you ever have some number that makes 0, it means that that's a factor. If you have some number, the same number that makes two polynomials 0, it means they have a common factor. We've got a common factor here. In fact, if you were to factor this is going to give you x plus 1, x minus 1, over x minus 1. Agreed? Okay. Do you see anything that simplifies out of that? Aha. Now this is cool. Now this is interesting, very interesting. What we're going to do is we're going to be able to simplify out this thing. Now I know what you're thinking. Well, wait a second. Can't you not simplify out a domain issue? Isn't that a problem for you? And the answer is yes and no. It would be a problem normally. However, watch carefully. Are we actually letting x equal 1? Is q actually getting to the point P? No. So is x actually equaling 1? No. We're getting really, really close. I'm talking like 1.00000 forever and then a little bitty 1 at the very end of it. Really close. But it's never actually equaling 1. So keep in mind, when we do this, we're not getting rid of any, we're not really altering the domain whatsoever because we already knew x wasn't equal 1. So we have this little restraint already, x isn't going to equal 1. So then what we know is, okay, the slope of the secant now equals x plus 1. Were there any questions on this? Because I got to erase it. Do you have anything? All right. Is this making sense to you? Do you see where the slope formula came from? Do you see how we can factor and simplify it? And now we get down to here. We don't have any problems. We're not eliminating domain issue because we're actually not letting x get equal to 1. It's just getting really close to it. Here's the jump that we're going to make, okay? Here's the jump.
Do you remember whenever I talked to you about my garden and the attacks it's been through?
Yeah.
So they've gotten a lot worse.
Oh no.
All
Why?
the lettuces, I don't know. It's just like these animals are evil or something.
How many animals do you have over there?
I guess there's like a few groundhogs.
Aw, man.
The chipmunks are the real problem. They're mean.
Kill them.
Heck no. I mean, you maybe, but that's
Poison
also
the
kinda
crops, kill them all, and then restart.
All the lettuce is gone. My beets have been torn through, so they're probably gonna die.
Bro, you can't let them get away with this. I'm not gonna lie. You're gonna have to go hunting.
That would be awesome, but no.
Grab a
As long as they don't
sniper.
touch my potatoes, I'm fine.
Just grab a sniper. Look from your whatever window in the house looks at your garden. Just have it posted up, and then just start blasting them whenever they come over. It's gonna be like Plants vs Zombies.
Except the zombies are just animals.
Yeah, except the
small
plants are
animals.
defenseless. You're the murderer, and then the zombies are also defenseless.
I don't understand that. They're like jerks, though. There's like this. We have 2 flower pots down there, right?
Mm-hmm.
And they know for a fact that they can't eat the flowers because there's nothing edible on them. But they
Right.
just dig them up.
What?
Yeah.
Now what? Okay, that's kill them all. We're about to do some groundhog genocide over here.
So I had to go out there and like put. So we have a fence over there now around the whole garden bed. and I went around and I put like forks sticking up around like the flower pots in the front.
Uh-huh.
See if that works. But I don't know. They seem a lot smarter than that.
I don't think a fence is gonna stop them.
Not the chipmunk. I mean, the groundhogs for sure. Because they're the ones that are like eating the vegetables. The chipmunks are the ones that are just digging around in there for no reason.
Yeah, that's annoying. Was this a problem at first?
No, not at all. Not until probably like just a few weeks ago. I don't know what happened. I don't know if they just all decided to wake up from their hibernation.
I wonder if they like found it and then now they won't forget about it. Now they know it's just like infinite food. Yeah, that's unfortunate. Like I said, just kill them all. Get it over with.
So that was true. That's what we have down. What I'm asking you is, as Q gets closer to P, so basically as X gets closer to 1, what happens?
Also, my peppers are like shriveling up for no reason as well.
For no reason.
Yeah, for no reason. I don't know what it is. There's like this one that's still going. Not sure how or what it's doing down there,
Okay.
but all the other ones are like brown and yellow, and they haven't grown at all.
Man.
So it's like, okay, well, tomatoes are doing fine. They're doing all right. They're starting to bloom. Probably gonna be fruit soon.
I mean, that's good. I don't know, do groundhogs not eat tomatoes or something?
I hope not.
What happens?
I'm gonna look it up. Do groundhogs eat tomatoes?
It better not.
Yeah, they do.
Oh my god.
So that's what they just don't like the taste of them. So they're coming next. Once they eat everything else, they're going for the tomatoes.
They already ate my kohlrabi. They're like 2 of them are leafless. They're just barren. They're bald.
Nice.
So those are probably gonna die. I don't think the other ones are gonna survive very long either. I'm just gonna come for those ones next.
Probably. Hey, what can you do? Kill them. That's
I
what you
guess
can do.
nothing.
That's not a rhetorical question.
As long as they don't touch my potatoes,
Mm,
completely fine. Because potatoes are like the best thing in there.
true. So say if you catch a groundhog somehow, and you chop its head off, and then leave its head just like lying there. Do you think it'll scare off the other groundhogs?
I don't know if they're. I mean, I don't know how smart they are.
If groundhogs,
I'm sure it
See-
attract like a hawk or something, and so then they'd be scared.
oh, that
back.
creates a whole new problem, doesn't it?
Well, the hawk would be good because it just like eat all the chipmunks.
Well, it doesn't eat plants.
No, I don't think so. Or if it does eat plants, it's just like seeds or something.
Do hawks eat plants? Oh, they don't eat plants. Okay. So no, that worked. That's perfect. If a groundhog sees a dead groundhog, will it be scared? It's only telling me they're scared of their shadow. Come on, but if groundhogs are scared of their shadow, they gotta be scared of dead groundhogs, right? Surely. That's like us being scared of like, I don't even know. That's like us being scared of mice, but not being scared of like a murderer or something, right?
Some.
Hey, well, we could try. We could just get a dead groundhog, chop its head off, maybe put it on a stick or something, like a scarecrow.
I think I'm good. I'm
The
alright.
groundhog scarecrow. You're gonna have to do one for every animal though, because
Oh,
maybe
no.
because other animals will probably see a dead groundhog and be like, "Oh, that's tasty or something. So you gotta have like some for each animal. Scare them off.
That's horrible. Oh no.
Okay, I mean, if a human head was
I want to protect my vegetables, you know, but
yeah, I mean, if a human head was in a garden, I don't think you're gonna have many thieves over there, honestly. You know.
I don't know. I think I'd have like the police track the police, you know.
Yeah, I don't know, man.
As Q gets closer to P, that means the X variable is getting closer to 1.
I think my one prevailing theory is that there's no hawks around, right?
Uh-huh.
And so that's why all these animals are doing all this crazy stuff, because there's no one to keep them in check.
Okay, well, how do you get the hawks to come over?
No idea. I guess like I was looking up online. It's like, oh, plant a tree. Like I got plenty around here. I don't need to do that. So I'm like, okay, well, I guess we just gotta wait. Because this has not happened like any of the other years. There was no like digging, or there wasn't. It wasn't as bad if there was.
Mm-hmm.
So.
It says, Hawks loves drums. If you want to attract hawks and eagles into
yeah.
your yard, get a drum.
I'm not sure about that one.
This would be drumming all day to get some hawks out and watch as like a bunch of hawks start flying over, circling around your garden and swooping up the groundhogs. That'd be so sick. Okay, they love voles, rats, rabbits, and ground squirrels.
We got plenty of those, probably.
Yeah.
Well, they better be coming around soon.
Or you could get some dead groundhogs, scatter them all over the place. I think that worked pretty well.
I don't know if there's like a big supplier of like dead groundhogs.
You gotta be the supplier. You gotta supply yourself. Supply yourself with dead ground. I could supply you with dead groundhogs.
Really?
Yeah, I'll put some salad in the garden that I get from like Walmart or something, right in my yard. Have some groundhogs come up to it, and I'll be waiting with like a big knife or something, and then I'll be like under like a cardboard box maybe, and then I'll just hop out of the cardboard box and then stab them.
It's a good idea, yeah.
Yeah. And maybe I'll have like a hole or something out of the cardboard box so I can peek through. You know? I see the groundhog eating the salad and kill it.
Maybe if maybe I'll just like dig a hole in my yard, right? Put like a piece of cloth over it. Put like what's left of my lettuce on top. So when they go to eat it, they just fall through.
I don't think they're that stupid.
I mean, they're scared of their own shadows. I don't know.
I don't think that. Okay, maybe they do that. I don't think it'd stop them much though. Like it have to be a huge hole.
I guess, yeah.
Because wouldn't they just climb right? They're climbers, aren't they? They got the claws.
They also could probably just dig their way out, I'd imagine. So
probably. That's like having a trap for like a fish or something and having it be full of water. You know? It's not gonna really stop them much. If you get a silencer for your sniper, it's not gonna be that loud. Come on.
I don't know if a silencer works the same way it does in movies.
Yes, it does. It's almost inaudible. Okay. You know, in Breaking Bad, whenever Todd shoots Jesse's girlfriend in the middle of a neighborhood, in the middle of the night, and you can't hear it because it has a silencer.
Can you tell me what happens to the value of...
Or like when Todd shot the one kid on riding the bicycle.
True.
Who was that, by the way? I only watched the clip, so I don't have
The
any other
kid?
context. Yeah.
Okay, so the scene before that, they were doing a train heist for some
Uh-huh.
more this one product you need to make meth. Some
Uh-huh.
thing, I don't even know what it is. But they needed more of it basically. It's kind of hard to get. So they did a whole train heist, and right after the heist, they got all they needed, and they were like super happy. And then this kid comes out of nowhere on his bike, and then sees them at the end with all the thing they need for meth, and they Todd just shoots him like without like even
So
thinking
there
twice
was
about it.
just like really no context. He just shot
Pretty much. No, it's not like he was there on purpose.
him.
He was just over there, and then Todd waves and then shoots him.
Wow.
And yeah, everything got kind of crazy.
Let's try some, okay? Think about this for a second. Just do a little bit of math with me. Let's say we started at the point 416, so x would now be 4. Plug in 4 here, how much would you get? Okay, now let's move it down to 3. Plug in 3 here, what would you get? Move it down to 2, how much would you get? Okay, move it down to 1.5, how much would you get? 2.5. Move it down to 1.3.
So you know the Chris Chan like documentary thing?
Yeah.
So there's a new episode coming out soon.
How are they even getting more content?
I honestly have no idea. I don't know if he's like still doing stuff after he got released from prison, or if like there's so much that we haven't uncovered yet. Which doesn't make sense because he recorded like every day of his life. But
So does Chris Chan not have a YouTube channel anymore? Did he delete it?
well, it's not deleted. It's the one that got hacked. But I don't know if he uses anything else. He probably does, but doesn't post anything on it anymore.
I think I see it.
It's like CWC Guardian.
Yeah.
Yeah.
Is Barb dead?
No, she's still alive.
Really?
Which is, yeah, I think so. His father's dead. He
Oh.
died in, like 2012, 2011. I was looking at one of those documentary videos today. Apparently, like, something that aided in his death was because of the amount of bug bites that he had whenever he went to the hospital for, like, a heart attack.
Really?
So there was just, like, so many of these bug bites on him because there was, like, the hoarding situation in the house.
Oh, because of the hoarding.
Yeah,
Dang.
yeah.
How do you know that he's gonna make a new video?
I think he posted something about it on the what's the one thing you can do? It's the YouTube post thing.
Okay.
I guess. He
Last one was
doing
only a
the
month
news-
ago. How's he getting more stuff?
No idea.
Part 76.
An insane individual. I find it so funny that like the sightings have just turned into like Bigfoot sightings,
It's pretty cool.
just like hanging around a Walmart or something.
Oh, Nick, he's not caught up to the present yet. The guy who's making a
Oh.
documentary.
Oh, are you serious?
Yeah, the latest video he made is like behind.
How far behind?
I'm not sure. I see a comment that says, "I can't imagine how it must be for you, but I maintain this vague sense/hope that your documentary series will catch up to the present, because the jail arc compressed a lot of time."
Oh.
Yeah, because there was this big filler arc called the jail arc. It was a filler
Oh,
arc.
God.
So hopefully, they can catch up now, but who knows?
I think there's been like multiple jail arcs. That's the thing. Because I remember he, in the one episode I was watching earlier today, forget which one it was, but he like ran over a store owner, his mom ran over a store owner.
Mm-hmm.
He switched seats with his mom in the car, and then he ran over the store owner again.
What?
And the store owner was like such a giga chad that he didn't even want to like press charges for that kind of thing. Because what happened was, he kicked Chris Chan out of his store or whatever.
Yeah, for
Because
probably
he kinda
valid
had to.
reasons.
Yeah, for valid reasons. And so, he only wanted to press charges for like trespassing or something like that. He didn't even want to like do anything else because his father, Chris Chan's father, recently died at
Right.
that point. And so, all he wanted to do was just
Yeah, he just didn't want him there.
press charges. Yeah. So, even though he got ran over with a car twice, he just seemingly did not care.
It's crazy. So Chris Chan can drive then? Or
Um,
was that illegal? Illegally driving and illegally just running somebody over?
Well, I don't think he was like 20 something at the time, so
Mm-hmm.
he probably has his driver's license, I would imagine.
Yeah.
Or he probably had his driver's license. He probably does not anymore.
Yeah, yeah. As this guy Phil said in the comments, we're always happy to wait and avoid people who make up-to-date videos about post-jail sightings, etc. They're disrespecting the series by jumping ahead. Like, I don't understand that, because this is how the series continues, because people are making videos. Latest Chris Chan sighting.
As I'm sure many of you know, Chris Chan feces.
I think one of the ones he was
Really hard
in
for
like
him.
some convenience
Top
store and he like
dangerous
reeked to
store.
high hell.
Yeah.
That's what the Redditor said. Whatever it was.
There's so many pictures.
They maxed out. Another observation I've made is the time of all of these sightings. Photographed 3 times at the beginning.
Well, I'd imagine that like everybody by this
The
point
updates
knows
out
who
fast
and
and on time.
what he looks like.
Please let
I'm not gonna lie,
So
some
as
people
soon
are
as they
probably
see
just
him-
taking pictures, not even knowing who he is though. Just 'cause, you know what I mean?
You're right.
little concept of
Chris Chan spotted in disguise.
Hell, and they explain
So he's disguising now?
Well, I mean, it's kind of, I guess.
Or is that just how he dresses?
I think that's just how he dresses.
Yeah, probably.
It's like the tennis shoes and the
Yeah?
skirt.
Do they look as awesome as the game pieces?
Wait, there's lots of other characters if you don't like the Pixie Sorcerer.
No, there aren't. They're all just the same with different costumes.
Man, I gotta close my window.
Move it down to 1.1, what would you get? Move it down to 1.01, what would you get?
I've noticed that, like, just having my window open or being outside,
Yeah,
I cough a lot more now.
really. Oh yeah, because of the air pollution.
Smoke. Yeah.
Yeah. Still like gray outside all the time.
Mhm. Looks like it's getting worse. It's like,
Yeah, doesn't it? It's crazy.
it's I think it was around like 2 o'clock, and every day I keep thinking it's gonna rain because it starts getting the weird dark sky color.
It just doesn't.
But I think it's just straight up the smoke. Yeah.
Yeah.
Can't can't imagine living in New York right now, though.
Yeah, imagine. New York already has bad air pollution, so then you add in everything from the
Right, yeah.
wildfires in Canada. It's like horrible down there.
Mm-hmm.
Pittsburgh must be pretty bad too.
I went there. It was actually like a little bit better.
Really?
I'd say. Yeah. Well, because it's further westward, and so it's not directly in the path of the smoke.
0.01. Good. Move down to 1.00001. What would you get? Move down to 1.00000 forever, and then a little 1 at the end. What would you get? 2.0 forever and little 1. Wouldn't you? Would you say that as this thing gets closer to 1, the slope of our secant gets closer to 2? Would you say that? Because I'm plugging in things really close to 1, I'm going to get out things that are plus 1, really close to 2. Does that make sense to you? Our secant's going to be really close to 2. Here's what that says. This lets us make the jump. This is a limiting position. It says that we know the limit of the slope of the secant line is 2. What that means for us is that the slope of the tangent line actually is 2. That's the jump. It says the secant line at this point, if x gets super, super close, really, really close, if x gets really, really close to 1, the secant line gets really, really close to 2. Now, I can't let x equal 1, but I can make the jump that if I could let x equal 1, the slope would be 2. That's the jump there. Do you guys see the jump? This is the using limits to make the jump between a secant and a tangent. So because the secant's approaching 2, we say, okay, we got this. That's called a limit. We're going to talk more about limits later.
I had to uninstall so many Steam games the other day just to get some space on my computer.
How many games did you have installed?
It was like, I can just check. So I had 10, and then I had to uninstall 6. So now I got 4 Steam games open on my desktop.
How much space do you have on your computer?
Well, the thing is, I have plenty, but it always goes straight to the local disk. For
Oh,
no
okay.
reason. And I could probably fix that.
Yeah, you can. It did that for me too. I had to fix it.
Yeah.
How much
I
is in
always
your
forget how,
How much is in
so-
your D drive?
Literally only 10. Wait, yeah, just 100 gigabytes. I still have like 2 terabytes left in there.
Really?
Yeah.
Yeah, I'm using like 0.09 terabytes. Or yeah, 0.09 terabytes on my D drive. I have 1.72 terabytes free.
Huh.
What do you even have installed? Fortnite? CSGO? Kovacs? Half-Life? Oh, that's like in Portal and TF2. Terraria. 6 Siege. Wait, is stuff getting installed on my other drive? I feel like it is.
On your local drive?
It might be, yeah, because I have like nothing on my D drive. I don't even know. Whatever, it's working right now, so.
Oh, right, yeah.
I
find
might
that
end up
so
having
fun
to
that the
delete some
local
stuff.
drive is prioritized, though.
Yeah.
It's the smaller one anyway.
never touches P. That's the idea of a limit. It gets really, really close. So the slope of the secant line is 2. What that means for us is that the slope of the tangent line actually is 2. That's the jump. It says the secant line at this point, if x gets super, super close, really, really close, if x gets really, really close to 1, the secant line gets really, really close to 2. Now I can't let x equal 1, but I can make the jump that if I could let x equal 1, the slope would be 2. That's the jump there. Do you guys see the jump? This is the using limits to make the jump between a secant and a tangent. So because the secant's approaching 2, we say, okay, we got this. That's called a limit. We're going to talk more about limits later on. But the jump is going from here to here. Now can you fill out this equation using that information? Sure. We know that it would be y minus y1, which is 1, equals the slope of the tangent. Hey, we know it's 2, x minus 1. Now, of course, we don't generally leave things in point slope. We'll solve them. Do you see where the 1, and the 2 are coming from, folks? Our point is 1, 1. Our slope is now 2. That's the slope of the tangent. If we solve it, we get y minus 1 equals 2x minus 2. Add the 1, y equals 2x minus 1. That's the slope of a curve at a freaking point. That's awesome. Oh my gosh, isn't that cool? We just found the first tangent line to a curve that you've done. Now granted, it's not a very hard curve, but here's what it is. I'll show it to you. You can actually graph it. Here's minus 1, it crosses there. You go up 2, 1, 2, over 1. Oh, that's the point. And if I graph it, it intersects at only one spot. That's it. That's a tangent line. Isn't that awesome? Your mind should be blown. Is that why you're looking to be stunned? Like, yeah. Is that your stunned face? It should be your stunned face. Okay.
Professor Leonard actually found the equation of a tangent line at y equals x squared at the point 1, 1. That's insane. Bro's a magician.
Get a good Chad.
Honestly.
It looks like one.
He is one.
Now,
True.
by show of hands, after 40 minutes of doing one example, how many people have we talked about? Good. You have down right now the basic idea for calculus. This is the basic idea. Using limits to find this tangent of a curve at a point. Is it going to get more advanced than this? Yes, of course it is. But that's the basic idea. Now we're going to do things differently when we actually get to the calculus.
Do you think Professor Leonard is just the guy that the math wizard was talking about when he had the story of the guy who can manage his time perfectly in school?
Yo, that might be it. That could be him, dude. I don't know though, cause this guy, he was saying like he made fun of the people on it's like the math team in school or whatever. he's like, yeah, you know the math team? Oh, I made fun of those people in college, but I was doing some other stuff. But you guys should do it.
But we will get there.
You know, maybe he was just talking about going to the gym.
Maybe.
The next thing we got to talk about is the different problem. I'm not going to spend a whole lot of time on it. I'm basically just going to introduce it to you because I know for sure you guys are not going to remember this by the time we actually get to area under a curve, so I'm going to reintroduce it to you again. But for right now, I want you to just get the idea about what's going to happen later on.
The math team was probably a bunch of nerds anyway.
True.
Okay, so the area problem. Here's the area problem. Area problem says, can you find the area under a curve between 2 points? The answer is yes, you can with calculus. Only how are we supposed to do this thing and let limits work for us. Here's the plan. Firstly, can you find the area the way it is right now? No, it's got a curve to it. You can't find areas.
Have you ever watched Picos Hank on YouTube?
Nope. Who's that?
Guy that does like tornado watching stuff. Like photographs them.
Let's see. So this is why you wanted to go to like the Midwest or whatever.
Yeah, because I was like, yeah, this is cool. This goes hard.
Top 10 best tornadoes.
He's got like a recap video for every year. So it's like 2019, 2020.
Nice. What are the top 10 best tornadoes, I wonder?
Tornadoes are often experienced through shaky viewfinders while navigating through chaos and adrenaline. But every now and then you find yourself in just the right spot to just marvel at Mother Nature's magnificence.
Right there. Look at that.
Number 10 on this countdown was an extremely close, freakish, stationary tornado. A beautiful angel of death twirling with all the mystery of a ballerina's ghost. Trees hover above. Destruction and death tolls are not considered in this countdown, rather tornado structure, beauty, or overall incredibleness. And this next monster is by far the least beautiful tornado in this video.
All right, this is gonna get really ugly really fast here.
This tornado claimed 8 people's lives, including 4 storm chasers. 151 others were
I think
injured.
there was one video of his where in the middle of it, he was like chasing some small little baby tornado. And then it dispersed, and then like this giant massive one came out of nowhere.
Oh
and just
no!
heading straight for him. And I was like, oh my god, that's so cool.
That'd be
Mobile
terrifying.
Doppler recorded
It was baiting him.
295-mile-per-hour
That'd be
winds
awesome.
just above the surface as this tornado grew to a record-breaking 2.6 miles wide, the widest ever recorded. Over most of this mega twister's 40-minute lifespan, it was a non-photogenic blob.
Look at the size of that monster.
It's the mind-blowing stats that landed the famous El Reno 2013 tornado number 9 on this list. Scenario, tones. All right, number 1 takes us back south of Dodge City to that unprecedented day, May 24th, 2016. At least a dozen tornadoes touched down, but the first one was the ultimate beautiful tornado.
That's what we came to see. It's conception of the gods.
The number 1 best tornado is
Approximately
pretty
30
sick, I'm
minutes,
not gonna lie.
This slow-moving, perfect
What's
beauty
the name of it?
presented the tornado of a lifetime.
It's about as fast.
Tones.
The ultimate
All
beautiful,
right. Number
beautiful
1
tornado.
takes us back
Oh.
south of Dodge City to that unprecedented day, May 24th, 2016. At least a dozen tornadoes touched down, but the first one was the ultimate beautiful tornado.
That's what we came to see. Big as this hail. Big as this hail.
So what maybe would be an idea?
You can approximate it by making it like a rectangle.
Oh, I could, yeah, sure. If I did this and said, okay, from here, I just want to make a rectangle. Would that be an approximation? Mm-hmm. Would it be a good approximation? No, not really. However, what if I did, okay, I don't want...
After I
just
watched his
rectangle.
videos,
Yeah,
I started
yes.
looking into some of the like more dangerous storms.
Yeah.
And there's like this one like horrifying one where it was sometime in like 1940s, I think 1930s.
Mm-hmm.
It traveled like 100 miles across the Midwest, killing thousands of people.
What the?
But I don't even
How
know if
many?
it's possible. Like thousands.
How?
I don't know. I'm pretty sure I don't think it was just one tornado. It was probably like
couldn't have
multiple, and
been.
they just got classified as the same one.
There's no shot
But-
one tornado did all that.
Yeah.
How did
Which
it
is-
live for so long?
I don't know. I think that's like the big suspicious part about it.
Yeah.
Because it's like, usually tornadoes will at most be up there for just a few minutes.
Yeah.
So for it to be up there for a few hours, it's
That's
like
kinda
more
crazy.
than 10 hours.
It's taking performance enhancing drugs, I think.
For what?
It's taking performance enhancing drugs.
Who is?
Tornado.
Oh. I guess, yeah.
It's unfair.
True. There's another where it was like, the tornado looked like it was walking.
Bruh.
So it had like two like cones just stepping on the ground almost. It's called like the dead man walking. I can only imagine like the storms that the native like Indian people saw
Mm-hmm.
throughout like the thousands of years that they were here.
They probably just rode their, what they have over there, llamas. I don't know.
I got like sucked up by the tornado.
Yeah.
Been horrifying though. If only they could have like wrote stuff down, that'd been cool.
They could what?
Wrote stuff down.
What do you mean?
Like, cause they only did like the oral tradition thing.
Mm-hmm.
So they never actually documented it, they just talked about it. And so then
True.
eventually no one knows about like a massive event that could have happened.
Yeah, we need that. We need to ask them the top 10 tornadoes. They'll probably have a different idea. I wonder if the Indians made like if they domesticated more animals, okay,
Mhm.
and they were, that means more diseases and stuff, right? And they lived near the animals and all that.
Oh.
So they live near the animals and all that. They got more diseases. Would they be able to like do a disease fight with the West? You know what I mean? Like, say they have a bunch of diseases, and so does the West, and then, or the East, I mean, and then they just start fighting with diseases. You know what I mean?
Well, I don't know. I think they were too weak to do. Like, so the West did that.
Yeah.
So, like, when the Europeans came in, they, like, handed them blankets and were like, alright, sleep tight. And those blankets were just covered in, like, the plague or something.
Well, they didn't even have to do that, though. They just, like, existed, and that was a problem.
Right.
That's what I mean. Like, what if they both had, like, a ton of diseases? They were both existing. Do you think it'd be, like, a disease fight? Like, what disease is, like, stronger?
I don't know if that would happen. I think it's whoever has, like, more immunity to, like, the disease. So, like, because the Europeans already had immunity to their own diseases,
Uh-huh.
and because the Native American diseases were probably, like, a lot more tame, since there wasn't like a million of them hanging around each other. There was only like a few, maybe like 100 or maybe 1,000 in any given place.
Yeah.
And so the diseases are probably a lot more tame, and so they're not really immune to anything. But like the animal thing, I mean, I don't know. It could have affected it, but that would also mean that there'd be like an entirely new civilization.
Yeah.
Be like, but I don't know if that would have mattered also, because I know that I think the Europeans were not as immune to like the Chinese diseases. So,
Wait,
like,
what?
they would die whenever they go over there. What'd you say?
Well, the East was all like connected though, and they already had like trade and everything going on, so they already had like, you know, they had this similar animals, similar diseases.
Right.
So it wasn't as bad as whenever they went over to the Indians and were like, look at all our stuff we got.
Mm-hmm.
It spread them all over.
Right.
But if the Indians had like really bad diseases though, but they had immunity, wouldn't like everybody just die? Because like the settlers are bringing diseases, they already have a bunch of diseases. Everybody dies except like a few. Wouldn't that happen? That would have been like bad.
Probably would have, yeah. Well, the settlers, because it'd be like, so it'd just be like 1 or 2 people coming in, like at first. They would probably die. People would hear about it and they'd be like, "Oh God, maybe we shouldn't go over there." That's what I think would happen.
True. Yeah, I'd probably be like, okay, never mind. This ain't God's plan to go over here, dude. We keep dying. I wonder if the damage would have already been done though.
I don't know.
Maybe they could have quarantined and killed the people who went over there. You know.
Right.
Alright, I gotta take my dog out real quickly. I'll be back.
Alright, too. You back yet? Alright, I guess not.
Alright, I'm back.
I want a rectangle from here to here.
You're back?
Yep.
Then a rectangle from here to here. Then one from here to here. And then one from here to here. Is that a better approximation? The missing area is smaller, yes? That's the idea behind the area problem. What we're going to be doing is making rectangles. Why rectangles? Well, let me ask you, can you find the area of a rectangle? That's why rectangles. And they're easy to draw. That's what I have. So if we make lots and lots and lots of little itty, teeny bitty, weeny little rectangles like that, all the same width, but going the entire length of our curve, and we add up all those rectangles, are we going to have a pretty good approximation of the area? And in fact, if we make those rectangles infinitesimally small, so whereas you couldn't even slip a piece of paper between them and then add them up, is that going to be even better? In fact, if we stuck an infinite number of rectangles between this point and this point, which you can do with limits, we're going to have a perfect area, and that's the idea for the area problem. You stick an infinite number of rectangles in there and add them up. It's going to involve limits because we're letting some number go to infinity. You can't ever reach infinity, but a limit will take care of that for you. That's the idea behind the area problem. Does it make sense? Kind of, the idea of the rectangles? Trust me, we'll get much more involved later. You have no idea how to do this right now. Don't worry about it, okay? We're not even going to do a problem. We'll do that later in chapter 4 or something like that. So, let's define a limit. What a limit says in English is, what does the function do as a variable approaches a given value? That's what it says in English. So, limits. What does the function do as the variable approaches a given value? That's the question. Now, do we care what happens to the function at that value? The answer is no. The limit isn't about getting to the actual point. It's about what happens as you're approaching that point, getting really, really close. You see the difference there. In the previous example, we couldn't actually get to 1. Do you remember why? Some of you are zoning. You're zoning out. You can't have 1 point on the line. We'd also make a undefined. What happens as you're approaching is no. That's the question. Now, do we care what happens to the function at that value? The answer is no. The limit isn't about getting to the actual point. It's about what happens as you're approaching that point, getting really, really close. You see the difference there. In the previous example, we couldn't actually get to 1. Do you remember? Do we care what happens to the function at that value? The answer is no. The limit isn't about getting to the actual point. It's about what happens as you're approaching that point, getting really, really close. You see the difference there. In the previous example, we couldn't actually get to 1. Do you remember why? Some of you are zoning. You're zoning out. You can't have 1 point on the line. We'd also make a undefined point, right? If you undefined, that would be bad. But we saw what happens when we get really close. The function got really close to something else. That's the idea of a limit. So we don't care what happens as you get to the value. What happens as you approach the value? For us, this is exactly what we did at undefined point, right? You can't have 1 point on the line. We'd also make a undefined zoning out. You can't have 1 point on the line. We'd also make a undefined point, right? If you undefined, that would be. You can't have 1 point. Some of you are zoning. You're zoning out. You can't have 1 point on the line. We'd also make a undefined point, right? If you undefined, that would be bad. But we saw what happens when we get really close. The function got really close to something else. That's the idea of a limit. So we don't care what happens as you get to the value. What happens as you approach the value? For us, this is exactly what we did actually, kind of in our heads. What happens what happens to x squared as x approaches, let's do 2. That's x approaches 2. I could have written it in English, but that's just as valid. What happens as x approaches 2? Now, do we care what happens if you plug in 2? No.
Apparently Chris Chan was supposed to appear on an episode of Dr. Phil.
Oh, but it never happened?
Yeah, he watched a few episodes and was like, nah, I'm not gonna do that.
Well, was it actually like a serious like consideration, or?
I think so.
Or were they like, oh, the Dr. Phil. Oh wait, Dr. Phil mean, I don't want to do it no more. Dr. Phil too mean. Because I'm guessing it would be more like that.
Probably, honestly. He was smart though, I mean, I guess.
Who? Chris Chan?
Yeah.
You think?
So, like, cause he researched the show before he was supposed to go in, and then like canceled it pretty much. He was like, no, I'm not doing this.
I guess he's smart in certain ways, I guess.
He also drove to a game place while drunk, without crashing.
Wait, he drove where?
He drove to some game place while drunk.
Seriously? Jeez, dude.
He's a good driver, you know? He's able to drive while drunk.
Secret to driving drunk is to always drive drunk.
Exactly.
There you go. And it's a skill.
What's going to happen if I draw this table right here with x and f of x? I say, I'm trying to get to 2. I don't care what that value is. What I'm trying to see is what the function is doing as I'm getting close to that thing. So what's happening as we approach it from the right? What's happening as we approach it from the left? Give me some, oh yeah, I already ruined it. Give me some numbers to the right of 2. Some numbers to the right. 3. Give me something smaller than 3. Like 2.5 is good. I like that. That's what I was about to write. So I almost ruined it. Give me something a little bit closer to 2. Closer than that.
On the first serious drive of his life that wasn't to the local game store, Chris locked himself out of his car on the side of the road in the middle of nowhere and had to be rescued by AAA.
Bro, what? Why do you do that?
I don't know. I'm reading like comments to see like this stuff.
Bruh. Did he do that on purpose, I wonder?
No idea.
For funny? For the funny?
Or 2.01. We want really close, right? So 2.1 and then maybe 2.001. That's pretty close.
God.
Take your calculators out, by the way. Now let's go the other way. Give me a number that's smaller than 2 that we want to work our way up from this way.
1.99.
Okay. Sure. How about we keep it kind of symmetrical? 1.5. I like that one. We'll do 1.9. All right. And 1.999. How about that? Does that work for you? Take those numbers, our function's x squared. Let's look what happens to the function as we plug those things in. If you plug in 2.5, what do you get when you plug 6.25 or something like that? Plug in 2.5. Do you get 6.25?
Yeah.
Okay. So we'd start with 6.25. What we care about is, does this side, look at the board, if we go this way and we go this way, do they meet up at the same point? That's what we're talking about for limits. Now this is a very easy example. We just were working with x squared. We know the answer is going to be 4, right? Or at least it should be 4. We're going to see if that actually happens when we evaluate our limits. Plug in 2.1, someone out there. Tell me what you get when you plug in 2.1, would you? 4.41? Okay, that's closer to 4. Tell me what you get when you plug in 2.001. 2.000. Wait, what's it?
4.004001.
How about that? Like that? How about 1.5? Oh, that's 225, isn't it? How about 1.9? Plug in 1.9. What do you get when you do that? X squared. 3 point. And now do 1.999. 1.999. What do you get? How much?
3.960.
3.960?
Come on. Emma.
Yeah? Okay, cool. What's going on here? Let's see. With a limit, we really don't care about what happens at 2. Because a lot of times, with a limit, we really don't care about what happens at 2. Because a lot of times, what you're going to find out is that we deal with limits where you can't get to that number. Because for some reason it's undefined, like our slope problem we just had, okay? So we're trying to figure out what's happening from the right and from the left and see if those are heading towards the same exact value. Are they? We're going from 6 down to 4, down to 4.04. Where's this heading?
Towards 4.
Where's this heading?
Yo, Nick.
What's up?
It says Chris Chan walked into his local preschool with a Canon EOS Rebel camera to reportedly gather reference material for his new comic.
When was that?
No, I made that up.
Oh, okay. I love how it's like believable though.
I looked up a camera name just to like make it more believable. Make it super specific. I was like, Chris Chan, you could say anything about Chris Chan, it would be believable. Someone's gonna make something up.
It's heading towards 4. What we would say right now, this is how you write it. A couple notes about this. The function must approach the same value from both the left and the right. So this is from the right, this is from the left.
I have to look up what happened
The
to
function
Barbara.
must approach the same value from the left and the right for the limit
Yeah,
to exist.
she is still alive, right? Nick?
I'm checking.
Okay.
Yep, she's still alive.
Bruh.
She's 81.
If it does,
She doesn't look a
here's
day
how you
over
write
100.
the limit.
True.
What you do is you put a little. It does. Here's how you write.
She have dementia
the
or
limit.
something?
What you do.
Yeah.
Jeez.
If it does, here's how you write the limit. What you do is you put a little lim undercase, which kills me because I can only write in capitals. So you put the limit, you put the variable you're working with, you put that little arrow, which I already told you is approaching, and you put the value to which x is approaching.
I swear, the wiki page on this guy's life is like the funniest thing ever. Because like they caption the images as like the most random crap.
Some of those images on there are not funny though. They're more disgusting.
Is approaching.
True.
X is this one. Where are we trying to get to on our x?
This one says Barb,
We're trying to find out
comma,
what happens
emboldened
around
by
it.
her horde, comma, evolved into a Snorlax over time.
Bruh.
point x equals 2. Does that make sense?
Fat Barb
So you'd say the
sitting on the
limit
couch with
as
her
x
also
approaches
fat cat.
2 of your function. What was
We didn't have to do the cat like that. Come on.
our function? Say it again. X squared. The limit as x approaches 2 of our function is equal to. What did the function approach? Here's what this says in English, okay? Look at the board. What does the function approach as the value x approaches? What's the function approach as x approaches 2? What's it going to do? That's the limit.
Just when did you
general,
say
we have,
age was not kind to Barb? Period.
That's like unnecessary, man. Like, come on. Like,
It's
you
just her.
don't have to say
It's
that.
her, picture of her blowing out a candle on a birthday cake.
This will be the last.
Horrifyingly qualifies as foreshadowing.
We had a limit of a function is equal to some
Of
number.
artist
That's what
depiction.
capital L is. That would stand for the limit of this function as x approaches a. It's what the function's tending to do for both sides as x approaches one single value. The only thing that we need
Oh
to know
God,
is the
can I
limit
pause
really
it? Can I pause
depend
that
on
picture?
Getting to a.
No, I
Limit approaches
can't.
one.
Jesus.
Can't believe the Chris Chan documentary guy isn't caught up.
That's I thought he was. I thought he was like either documenting the new stuff going on or like finding stuff from before to document.
Mm-hmm.
I didn't know he was so far behind.
Yeah, I can't believe it. So hopefully by the time that he catches up to now, there should be more content.
Mm-hmm.
Single value. The only thing that we need to know is the limit really doesn't depend on getting to a. Or x is never going to equal a. X never gets a. We just care about what's happening to the value of the function as x is getting really close to a from both sides. Up here on the board, what's happening to the function as x is getting really, really close to a from both sides. It's getting really, really close to 4. That's the idea of a limit. How many people understand the idea of a limit? Cool. Next time we'll work on how to find some limits. All right, so if you remember from last time, we're talking about limits, and what we're realizing is that a limit basically says or asks the question, what is the function doing, what's the value of the function doing as x approaches a certain number? Now, do we ever care what happens when x gets to that number as far as a limit is concerned? No, not really, just what's the function doing? Where's it getting close to as we're getting close to that x value? And that's the idea.
I wonder if limits get more complicated. Like, they probably do, but... Because, like, it seems like all you do, from the ones that I've seen, is it says, like this one says, as x approaches 1, and then it has, like, an equation. So you just plug in 1 for x, and then that's your answer. You say, it approaches this value that you get whenever you plug in 1, as x approaches 1. You know what I mean?
Right.
Like, I wonder if it gets more, like, complex.
Here. So, when we're talking about
So what, are you just working with lines right now?
Well, here, I'll screenshot this thing. Alright, here. And there's not like a question yet, but like that thing on the right, that term on the right side, we could say that's like a function, so like f of x equals whatever's on the right side. So then the question would normally be like, what happens to f of x as x approaches 1? And then you plug in 1 and you say, okay, that's 0 over, okay, that's undefined, so let's just say it's 1, okay. Let's say when you plug in 1, it becomes 1. So you say, okay, f of x approaches 1 as x approaches 1, or something like that.
Right.
So then if it was 2, you'd say a different answer and all that. I'm wondering if it gets more complicated than that.
Well, I see that that's the vertical asymptote at 1, right?
Mm-hmm.
Is the undefined. So I'd imagine as you like rack up more and more of those asymptotes in a single equation, that's when the limits start becoming more complicated.
True.
Because you gotta account for all of those infinities.
True.
Of x minus 1 over x squared minus 1, that's our function. We want to find out what happens as x approaches 1. Now, why can't I figure out what happens when...
So what do you say for this? You say it approaches undefined? It approaches an undefined value. It depends on the question. I'm gonna see what the question is.
When x equals 1, tell me that. What happens as x approaches 1?
Well, I think it would be as it approaches 1, because 1 is the only undefined value. If you plug in any other number, it's not going to be undefined.
Yeah.
Why can't I figure out what happens when x equals 1? Tell me that. That would be undefined, right?
Yeah.
As a matter of fact, it makes both the numerator and denominator 0, and that would still be undefined. We found out that is that a hole or an asymptote? Do you remember? That's a hole. That's going to be a hole. Ultimately, this function has a hole. So what we want to find out, though, is what's the function doing as we approach that certain value? Now, one way we figured out, the only way we figured out these limits, is to make up a table. And this is kind of the elementary way that you discover limits right when you first learn. Now, towards the end of the day, I'll teach you some better ways on how to do this. For right now, though, I want you to see what happens with the function and with the limit. So when you are finding these, and your homework's going to ask you for that, find the limit of this function by making a table of. When you do that, you have your x values on the top, you have your f of x values on the bottom, in this case, x minus 1 over x squared minus 1, and you start with the number you want to find the limit of, the number that you want to find the limit of the function where x is approaching that certain value, put that in the middle. So for instance, you're going to put 1 right there. And really, I don't want to know what that is, because you can't plug it in anyway. What we want to find out is what's happening from both sides. Is it going to the same value? You follow me on this? So, what you need to do now, put these numbers in order because it is a number line. You don't want to have like, I see a lot of mistakes on this. I see a lot of people do this. Okay, well, I'm going to start at 2, and then I'm going to go to 1.5, and then I'm going to go to 1.1, then I'm going to go to 1.0001. Right. Do you see how that's the wrong way to do it? That's going to show you one direction, but it's the wrong direction. You need to have these numbers reversed so that this is just a little bit past 1. We're coming from the right-hand side. So if you want to find out where it's coming from, don't have 2.
So which Chris Chan documentary video are you on?
Well, I think I've skipped a lot.
No way you skipped.
Because I go back and forth all the time. So I think when I was doing my first watch through, I got up to about like number 8, and I was like, oh god, no, I can't do this, especially not in the gym.
Oh, is that bad?
Yeah.
Jeez. How does number 8 already start getting bad?
Well, because I think it was more of like, it was more depressing than anything because it was like, and in the beginning you kind of side with Chris because everyone else is just abusing him.
Yeah, and then Chris starts turning like deranged.
Starts turning like evil.
It's
Chris.
the Walter White arc.
So then you start hating him and you start siding with like the trolls and stuff.
You're like, come on, stop trolling the man. Oh man. Okay, never mind. The question is though, did the trolls make him that way, or was he always like that? And the trolls just brought it out. Who knows?
That's a question.
Philosophical question. Do you think if the internet didn't exist, Chris Chan would be like normal?
See, that's the problem. I don't, because not only is he, he has the autism or whatever, but he also
he's abused.
Like, it was abused and all that stuff, and like, the fact that he thought he was gonna be a kid forever probably didn't help much. So I don't know how much like no internet would have saved him. I mean, probably a lot. I'll be honest, it probably would have helped a lot, but who knows?
Yeah, I can never really tell.
Right here, have 2 over there somewhere if you're going to do that. Right, so these numbers that we have next to 1, they should actually be the numbers that are close to 1, all right, not the other way around. Are you following that? Nudge your head if you're okay with that. So we don't want to have the smallest numbers over here that are the ones that are closest to 1 over there. We want this just like a number line would look. So here, maybe we do start with 1.5, 1.01, 1.001. Make it really close to 1. Now the other way, I'll probably want to start with 0.5, right? I want to make it symmetrical at least a little bit. So where's 0.5 going to go? Is it going to go by the 1 or over here on the left-hand side? Left-hand side. I want the numbers that are really closest to 1, well, the closest to 1. That's going to show me the trend. So 0.5, maybe 0.99, and 0.999. What I'd like you to do right now on your own, take out your calculator, find those numbers. How about this? The people to the, let's see, this is your left. The people to the left side of the camera, do these ones, okay? People to the right side of the camera, do those ones. Can you do that for me? So plug into the function, tell me what you're getting out.
It's crazy how the Russo-Ukrainian war has been going on for more than a year now.
Has it?
Uh-huh.
Jeez, dude.
The Russians started using, like, Soviet-era tanks, because they keep running out.
Dude, how are the Russians still going?
I don't know.
What do you think's gonna happen after the war?
I think there's, like, multiple ways it could go down. I don't know, honestly.
Do you think there's any chance Russia comes out of this in any like good shape at all?
Probably not.
Yeah, I can't see that happen. I think the question is how bad is it gonna be for them?
Right. Because like if they're losing now, I don't see why they'd be able to win later. Like,
yeah,
it would make sense if they didn't have, if they weren't already mobilized. But because they already are, there's like nothing left for them to do.
Are they getting funded by China or something?
I don't think China's funding them, no.
Oh, then they're screwed. That's like the only chance they have of like making a comeback.
But they are getting, I think a lot of their oil revenue is like keeping them up.
Mm-hmm.
And apparently, the Ukrainians have to, they like buy stuff from Russia.
Yeah.
Or, no, is it the other way around? Something's happening where there's still like trade between the two. And it's probably just being used for like war. So.
That's
kinda
odd.
weird, but yeah.
Alright, I might get off for the night.